In this video, I want to kind of talk about what I did for this project. It's the A star node based pathfinding. So instead of using NavMesh, we are using graph nodes to connect the neighbors, and by doing so, running and also running a star algorithm, we're able to guide and also basically navigate. So our AI agents can go from the beginning of a spot and to the end. So first of all, what I did visually is that I added a widget blueprint on top of each waypoint blueprints. So each of these is a blueprint actor, is an actor in the level, and I slapped the widget blueprint onto it. And as you can see, it has G cost, H cost, and F cost. So G cost is the edge cost from the beginning, from the start point, right? So basically, it's going to this, and then go to this. So the length between these two will be 800. The distance between these two will be 400. Then you go to here. The distance between this will be 1600. So, yep. Consider these are the only pass, the shortest pass, as well as the only pass, and the edge, the heuristic cost, is the direct distant 2D between the current location of the actor with the end goal, right? It's which is over there, and the F cost is the addition of G and H, right? So this is the classic A star setup. And as we're talking, we can see that our agent is slowly moving towards the end. And also one thing I did is that we can take a let's take a well let's wait until I finish first. So one thing what I did is that during setup, which is very important because A star is all about setup. Nothing really is as real time. It's all about running and finding the shortest path, the most optimal path. Then we basically just let the AI follow the list, and that'll be it. So the first thing I did is I implemented or I define, right, or I define as origin and also as goal as two of the booleans set on specific um, actor of the waypoint in the actor, right? Waypoint of the level actors, right? The actors that's in the level. So this is way more like scalable instead of writing like hard code the location of the current of certain actors location, right? So this is more scalable. That's why I did it this way. And another thing is I tried to write every fundamentals, like the basic booleans, to declare it in C++, because, and you can see it's now achieving the goal. So what I want to talk about the most is that first of all, let's take a look at two of the classes that was really important. The first one is I extended the blueprint class, and now it has a waypoint base, and I'm able to basically set and initialize all the cost within C++. And because the reason why we do this is we want to run the algorithm on the C++ level instead of blueprint. Because I don't know. I like. There's definitely a tutorial out there. Doing shortest pass, shortest like pass finding algorithm in C++. But it just I don't. It just it's way more intuitive to do it in C++. If if that makes sense. So that's what I did. I read it in C++, and it's the classic A star, but I add a little, not like a twist, but like the way I read it is a little bit more greedy, is when we have the same total cost, the total F cost between different nodes, I would choose the lowest edge cost um graph node to start to begin to begin explore, if that makes sense, right? So normally you would want to pick, you want always want to pick the if cost and explore its neighbor, but when the if costs are equal to each other on different actors, um, I would like to explore the one with the lowest edge cost first. So that's a little that's the little that's the approach I chose, and it's working pretty fine. I don't know if it's the fastest, but it's definitely one of the good ones, right? Like good. I don't. Yeah, I think it's good. So besides the Pathfinder as well as the base class, yeah, I started with like using a widget component as the Sena component, basically like the root component of the class. But end up I couldn't rotate. I couldn't really rotate the widgets like without rotating the whole thing. So I was like, you know what? I'm just gonna write a widget blueprint and use that instead. Okay, so let's take a look at the blueprints. So what I did, let's take a look at the behavior tree first. So what we did first, right, is when the AIC, the AI controller initiate, we want to first of all set all the values, right? We want to basically reflect all the values into the blackboard, which doesn't, I guess it doesn't really matter. But then we want to set our, oh, well, I mean, first we want to set our closest waypoint nearby AI. So, so we have a spot to start with. And by doing this, we can technically, well, yeah, we can, like, we can place the actor anywhere inside of the level, right? So it will still work, it will still run. Let me drag it to the extremely far side. Okay, let's do this. Boom. Okay, let's take a look. So this is the previous run. It would start from 1615 and it will run now. Okay. Oh, sorry, my bad. It's because I didn't set this as a B start as original and I want to set the 1615 as not original, right? Okay. Then we want to spawn the player nearby our newly set original, right? So let's do this. Let's save. Then let's run. Right? As you can see, it's working as intended, and it explored every other spot, right? Every other nodes nearby it, and eventually it should reach the end. And the cost is almost like doubled than the nodes started from the center, right? So as we can see, it works, right? So the way I set it up, it's extremely scalable. Even you can like change a different level, or even put it into a like a triple A game. I'm not even kidding. Like as long as you have the exact same and like a simple setup, right? And another thing I did is that even though this neighbor is set up in BP, it's initialized in BP, it's declared in Blueprint, but I want to mess around with it in C++ as well. So one way I did it is I declared um, another list in C++ level, then I basically just set a reference in BP at I believe it's either begin play or constructor, right? Constructor. I believe it's constructor in BP. And yeah, let's take a sorry, I was a little bit distracted, so let's get back. So once the AIC is initiated, what I want to do is that I want to call the shortest path algorithm, basically C star, A star, my bad. So basically I want to call it A star. I'm not going into like too deep of detail into it. So basically I loop once, then I get the is origin and also is goal. Then I set both of the variables. And then I do the A star algorithm, and also normally A star algorithm would reconstruct and also return a pass, right? So the pass would be will be what we actually care about. So after we get a pass, we want to want to like iterate the pass as well, and want to get the node cost. Right. So this node cost is is a custom function that like based on position, blah blah blah. Doesn't really matter. So this doesn't really matter. And after this is done, we hook it up with the same value on the blackboard, right? So that's how you see the left up corner of the total cost thing, right? Like 600. So that's how you see. That's how you know. Okay, so after this is done, we get to know that when the AIC calls, we do the A star algorithm immediately. Not really immediately, but like we wait a little bit, then do it after. Then we initialize, basically hook up all the values with the ones in Blackboard. Then we run a loop. This is not, this is not gonna end, but like for the purpose of demonstrating, simply to put the actor to like move the actor alongside the nose and to the final goal. This does what it needs to do. So what I does is I want to choose the next waypoint based on what our current waypoint is, right? Current node, and then I want to move the actor, the AI agent actor, or pawn, whatever, towards, also, like push it towards the next waypoint. Then I want to check that if it's at the end. If it's already at the end, then we want to finish it. If it's not, I set the current I will set the current waypoint to the one that we moved into, if that makes sense. Okay, probably yeah. It's probably not the best because it's running per tick, but um, it works. Okay, it's probably not the best, but anyway. So yeah, I think this is mostly it, right? So this is like a pretty simple behavior tree setup, and yeah, and let me know, right? Let me know. Oh yeah, and also, we also, well, not like we, but like I also set up like a little debug functionality. Basically, when you press one, it would freeze, right? It will pause the game, and when you press two, it will run again. So yeah, and also when you press one, it will also show you. I will also print the current node and also the next node is going towards um onto the screen, so people can have a better time, or like easier time to I don't know how to say it, but like to visualize it better and also to know what is going on. So yeah, thanks for watching.